Hello everyone, my name is Techno, and today we are going to create a site-to-site VPN on AWS. So with that being said, let's get started. Today we're going to create a VPC, and this is going to simulate a connection between AWS, which is on the left-hand side, to your on-prem device, which is on the right-hand side. Unfortunately, I do not actually have on-prem devices, so I'll be simulating it by using another AWS configuration. Here we have a VPC, and this is an EC2 instance, right? So for the VPC, our CIDR is 192.168.0.0/16, and then our EC2 instance is 192.168.1.1. And we're going to create a site-to-site VPN, which has two tunnels, tunnel 1 and tunnel 2, to this router. Typically, we call your router a customer gateway, but it's usually a router or a firewall, just a way for you to connect your on-prem devices to the internet, or in this case, we're going to connect it to the site-to-site VPN. I'm going to show you how to do this on your command console. What we're going to do is create a EC2 instance as well as your VPC. Your VPC comes first and then the EC2 comes next. So you just type in VPC, click on that, click on VPCs. This is a default VPC. We could use this, but I'm going to create a completely new one just in case if you don't know how to. So we're going to create VPC, and typically over here you can create VPC only or VPC and more. Typically I like to do VPC and more because it saves so much time when you're creating your VPC or virtual private cloud. So we click on that. Our names, we're going to call this site-to-site VPC. And if we go back to our architecture, our IP address is 192.168.0.0/16. Type that in. Okay. We're not going to use IPv6 just for simplicity reasons. Number of availability zones. So just to go over this really quickly, AWS has multiple availability zones per region. So in case one goes down, at least you have multiple other availability zones to continue your EC2 instance or whatever you're trying to run. So in this case, we're just going to do one just so everything looks much more simpler and cleaner. Public subnets. This is where you can connect to your EC2 instance either by SSH or RDP, depending if you're using a Windows device or not. But in this case, we're just going to be using Linux, but we do need a public subnet so that way we can SSH into it. So we're going to click on just one or two, but in this case, we're just going to do 0 for simplicity reasons as well. Next, we have subnets. In this case, we have the NAT gateway, and for our testing purposes, we actually don't need a NAT gateway, but essentially the whole purpose of having a NAT gateway is, for example, you have a private subnet. You put a NAT gateway in the public subnet, so that way any instance in your private subnet can talk to your NAT gateway, which then forwards out to the public internet, rather than having a public subnet where it just goes straight to the internet. This is just used for security reasons in case you don't want people to access your EC2 instance from the internet. And then lastly, we have VPC endpoints. We actually don't need this, so we can just turn this off. And now we're going to create the VPC. All right, as you can see, this creates your VPC, your subnet. It also creates an internet gateway and a route table. So this is why whenever you create VPC, using that option is so helpful. And this is a bird's eye view of what your topology would look like. We're going to create a new EC2 instance, put it under this subnet, have it placed in the routing table. In this case, we're probably just going to put in the public route table, so that way you can go ahead and SSH into it or do whatever you need to do. And let's see, if we go to your, up here, if you type EC2, click on that. Click on instance running. Of course, there's no instances running because you have to create your new one. We're going to launch a new instance. Call this my server, or you can call it whatever you'd like to call it. We just need to create a dummy EC2 instance just because we can simulate your on-prem device connecting to whether that's like your server or any kind of application that you'd like to access. And then we're going to create Amazon Linux. Instead of doing 2023 AMI, I've actually just worked with this previous one. I just had better luck using Amazon Linux 2 rather than 2023. I tried to create a site-to-site VPN with this before, and I just had a lot of issues. So we're just going to select Amazon Linux 2. Don't worry about the architecture. We're still using the free tier. Just make sure that you're not running this for a long time because you might actually get charged. Key pair. I'm going to create a new key pair. Create a .ppk because we're going to be using putty, and then call this EC2 underscore key, and then create the key pair. And then as you can see, we just downloaded this key pair. I'll open that later. Now, network settings. This is where you want to make sure that you're on that same VPC that you just created. So right now this is the default VPC, but want this EC2 instance to be on this site-to-site VPC 192.168.0.0/16. Click on that. Subnet, this is the only subnet. If we created a public and a private, you would see the private subnet in the drop-down menu as well. Security group. By default, AWS creates your own security group. You don't actually need to create a new one if you don't want to, but in this case, I'm going to create a new one just so you can follow through with whatever I'm doing. Let's call this SSH/RDP/IC. If this was a Windows device, you can also add RDP onto the security group, but I'm pretty sure we don't need RDP since we're just using a Linux device and we can just SSH into it, but that's always an option for you. And for the description, same thing, you can just call it SSH, RDP, ICMP. Here you can see the inbound security group rules. Right now we already have SSH. This is the port, of course, 22. Source type, you can either do my IP or you can do a custom IP address range. For testing purposes, it's going to be anywhere because I'm going to delete this entire test once I'm done with this video. So good luck trying to SSH into it, but you won't have any luck. You can enable RDP, as you can see right here, but I don't really need it, but you can enable it if you'd like to. What I'm looking for is all ICMP IPv4. So that way we can ping the EC2 instance to make sure that it's actually reachable once we establish this public IP address and create this EC2 instance. And then after that, storage, that's not necessary, and launch instance. All ICMP, this is where you can click on anywhere. So that way you can ping it from, whatever device you'd like to ping it from. Launch instance. Every EC2 instance must have some kind of security group, both for inbound and outbound rules. As you can see, inbound rules is whatever is allowed to ping, inbound to that EC2 instance. So in this case, we only have SSH as well as ICMP. So those are the only two protocols that we will allow into the EC2 instance. As far as what the EC2 instance can do outbounds, usually by default, it's always quad zeros. So that way it can, ping any devices on the internet, but typically this is always quad zeros. I rarely touch outbound rules and only work with inbound rules, but in your situation, it might be different. The next thing to check is on the networking tab, you want to make sure that you check your route table as well as your network access control list. What you would have to do is click on subnet ID, open it in a new tab, and as you can see right over here, there's two tabs. There's network ACL and route table. So the second thing to check after your security group is your network ACL. I never touch this at all. In your case, you might actually work with network ACLs, but for me personally, I've never actually touched this. Keep in mind that network ACLs, these are stateless. If you create an inbound rule, you also need to make an outbound rule. Whereas for security groups, those are stateful. So for example, if you are trying to SSH or even ping outbounds, it will always go back inbounds because it's stateful. It remembers, okay, I reached to my destination and it should come back the same direction. Whereas for network ACLs, if you have an inbound rule, for example, okay, we'll allow ICMP, but you don't have an outbound, then it'll drop that outbound because it's not on this outbound rule. So just keep that in mind, but typically I like to keep it as default, which is quad zeros. The last thing to check on your network is to make sure that your internet or your traffic forwards out to the internet gateway, and it will forward out to your virtual private gateway. I'll explain more on that later. Essentially, quad zeros is forwarding over to your target network. In this case, it's the internet gateway that was automatically created when we created the VPC. You need to make sure it forwards to the internet gateway if you would like your EC2 instance to reach out to the public internet. If you would like to take a look at exactly what it's trying to do, you have to actually click on the route table. And then once it opens up that route table, you can click on routes, edit routes, and this is where you can add traffic. So in our diagram, we have the 10.0.0.0/16 network. And right now, I'm just showing you an example of what it should look like. The target should be a virtual private gateway, which is going to be your site-to-site VPN. The reason why it didn't populate is because we did not create a site-to-site VPN yet. But first, we can see and confirm that this instance that we just created is now in the running state, which is a good thing. Okay, so since we know that this instance is in the running state, if you click on details, it will tell you what the private IP is, as well as the public IP. Wait, I don't think I created the public IP. Oh boy. Well, this is a mistake that I made right here, and hopefully you don't make the same mistake. So we're going to actually create a new instance because I made a slight tiny mistake. This is where I missed it. Auto assign public IP. You want to make sure that you enable it so that way your instance has a public IP address. So that's the beauty of using AWS. Once you already create your security group, your VPC, all of that is already done for you, and you don't actually have to create a new one unless you're trying to create a new one. All right, so this one is now pending. For this one right here where it says my server, we can actually go ahead and just delete it. So instance state, terminate instance, and confirm. So now it's going to shut down and then delete once it's done. All right, my web server 2 is now created, or web server again. So what I was trying to show you is if you scroll down to details, it'll tell you the private IP as well as the public IP. Because it already has a public IP address as well as connects to or routes to the internet gateway, what we can do right now is actually ping it. Type in ping. You can actually click on this button here to copy the IP, ping, and then paste it. You see that? We're getting pings, which is great. That's how you know this instance is working and that it is reachable. So now the next step is to actually SSH into it. So in order to SSH into your EC2 instance, what you would need to do is open up PuTTY and then put in the IP address. So it's this IP, port 22. And then since we have the key pair, we can go ahead and click on authentication, private key file for authentication, click on browse. And then we can just go on to this on downloads, open, click on accept, log in by clicking on connect, SSH client, it says EC2 user. So that should be the username, EC2-user. And would you look at that? We're into this EC2 instance. We just SSH'd into it. Congratulations. This is just step 1, okay? We still have multiple steps to go. So we created this VPC. We created this EC2 instance. Now we're going to create our site-to-site VPN. And I might go through this a little bit quickly, but actually now that I think about it, before we create a site-to-site VPN, we need to create the other side, the on-premise side. So I'm going to simulate this same exact thing. So as you can see over here, our on-premise IP is 10.0.0.0/16. And even though this is a router, we're actually going to use this router as a EC2 instance. And for our router configuration, we're going to install StrongSwan onto it. And we're going to make sure that our StrongSwan is able to reach out to this other side of the VPC, 192.168.0.0/16. So technically on this on-premise configuration, we need to create 3 different things. Number 1, the VPC. Number 2, EC2 instance acting as a router. In this case, it's going to run StrongSwan. And lastly, another EC2 instance acting as our on-premise device. To simulate that this is from a completely different region, instead of going on to Ohio, I'll just go on to US East 1, which is North Virginia. Click on that. And we're going to do the same exact thing. Create a VPC and 2 other EC2 instances. VPC. This is the default VPC. Like I said, we can just ignore it and create a new one. VPC and more. Call this on-prem site. This is the right CIDR block, which is great. 1 AZ, 1 public subnet, 0 private subnets, no NAT gateways, VPC endpoints is none, and create. So far so good. Next up is to create the EC2 instance. Keep in mind, we are creating 2 completely different EC2 instances. So click over here, and I'll go through this very quickly once again. Let's call this StrongSwan. Amazon Linux 2. Like I said, I'm only using this because I've had way better luck doing this compared to my other one. Okay. VPC, click on this on-prem one. It's already assigned a public subnet. Auto-assign public IP, yep. Security group, if you click on existing security group, it should be blank because we didn't actually create a security group inside this North Virginia region. Yep, it only has a default. So we're going to create a new one. SSH/ICMP. Okay, same thing. SSH from anywhere. ICMP v4 from anywhere as well. And then we can create this EC2 instance. Actually, to save time, we can actually click on 2 instances because basically they're going to be the same thing. It's just that for StrongSwan, we're going to install the configuration file onto one of the instances. So now if we take a look, both of them are called StrongSwan. I'll keep this one as our StrongSwan configuration. This one will just be called on-prem device. Okay, cool. So remember, we need the public IP address, right? So for this StrongSwan, let's pretend that this is a router. And this is the public IP that comes with it. So we're going to copy that. On our original tab on the Ohio region, so make sure that you're on the VPC tab. So click on that, okay? And if you scroll all the way down, it goes to site-to-site VPN. Well, it goes customer gateway, virtual private gateway, and site-to-site VPN. So the first thing to do is create your customer gateway. To create a customer gateway, which is essentially just a logical device, which is going to be using your public IP address of your on-prem router. In this case, it's going to be StrongSwan. Let's call this StrongSwan _ customer gateway. We're actually not working with BGP, so you can ignore that. This is the IP address of that StrongSwan IP right over here, 54.161.110.174. You can ignore certificate ARN device. You can call this, Cisco or whatever manufacturer your firewall or customer gateway is. We can just leave this alone. Create customer gateway, very easy. Awesome. Next step, create your virtual private gateway. Now, just a quick note, on your site-to-site VPN, you can either use a virtual private gateway or a transit gateway. To dumb it down really quickly, virtual private gateways only allow you to connect to one VPC. Transit gateway allows you to connect to multiple VPCs. So that's up to you, but in this case, we only want to connect to one VPC, so we only need a virtual private gateway. Super easy. And then right over here for StrongSwan VPG, you want to attach this to your VPC. So click on attach to VPC and click on this site-to-site VPC and attach. Cool. Next step, we click on site-to-site VPN. Create VPN connection at the top right. Call this my_VPN. As you can see, you can either choose a virtual private gateway or a transit gateway. You can choose one or the other. And when you feel like you want to change your site-to-site VPN to a transit gateway, you always have the option available. So don't worry about that. Click on this virtual private gateway that we just created. Customer gateway, we can use the existing one that we just created as well, right over here. Now, routing options. Be very careful and be mindful when you're creating your site-to-site VPN. Once you create your site-to-site VPN and you choose static, for example, you can't change it back to dynamic or vice versa. So just keep that in mind. Static IP prefixes, let's just leave that alone for now. Local CIDR and remote CIDR. So really quickly, local is always going to be your on-prem device or on-prem IP address range. So if we go back to this diagram, it should be 10.0.0.0/16. So we can do that right now. Typically, I've seen a lot of people just use quad zeros on both. It doesn't really matter. But if you want to only limit it to your on-prem IP address range, we can do that now. Remote. This is on the AWS side. So in this topology or in this drawing, this is where your remote is located. So it should be 192.168.0.0/16. Again, you can always keep both of these as quad zeros. You don't actually need to specify it unless you want to. Now, tunnel 1, tunnel 2 options. I typically do everything on default, and the reason why is because you can edit all of this right here. Encryption algorithms, integrity algorithms, Diffie-Hellman groups, IKE versions, phase 1, phase 2 lifetimes. You can edit this to your heart's content, but for this simple example, we are not touching this at all. VPN logging. This is great. VPN loggings will actually tell you what is going on with your tunnel, why it's up, why it's down, basically what's going on with it. In this case, I am not going to turn on VPN logging. In my future videos, I can show you what the VPN logs will actually tell you. Tunnel maintenance. Every now and then, AWS will actually perform maintenance on your tunnel, and you have the ability to accept those tunnel maintenances. In this case, I'll turn it on. I don't think there's going to be any maintenance going on inside this tunnel anytime. Tunnel 2 copies the same exact thing as tunnel 1. So let's make sure that this is enabled and create. All right, as you can see, it is now pending. It takes usually 3 to 5 minutes for it to go to the available state. And if you scroll down here where it says tunnel details, ta-da, here is your VPN. This is your VPN endpoint number 1 and number 2. So in this architecture, we have now created everything we need to create, right? We got the AWS side, the VPC, the EC2, as well as the site-to-site VPN configured on-prem. We simulated it on AWS using a different region. We created 2 EC2 instances, one of which is going to be acting as a firewall, and it is going to be using StrongSwan. We are on the final stretch of creating this site-to-site VPN. While this is in the pending state, you can download configuration, and if I scroll down here, there's a whole bunch of different manufacturers, right? Like You got Cisco, you got Fortinet, Juniper. In this case, we're going to be using OpenSwan. And then we can leave everything alone. So right now this is Ike v1. We're just using a cookie cutter template. Ta-da! If we open it up, Amazon gives you every single detail that you need to make sure that this tunnel runs smoothly. So I will show you exactly what to do based on following these instructions. Now that you downloaded everything, we want to SSH onto this guy right here. In the beginning of the video, I showed you how to SSH into your EC2 instance using PuTTY. But what if you don't have PuTTY? Well, that's not a problem. You can click on here, EC2 Instance Connect. All you have to do is just make sure it's on EC2 Instance Connect and click on Connect. And it should, keyword should, let you connect to this EC2. Yep. Ta-da! So now if I wanted to ping Google, we have a response. So that means we can connect to the internet. Okay, now that we have this EC2 up and running, I will show you exactly how to install StrongSwan on it by following instructions. The first step is to make sure that you install OpenSwan or StrongSwan. So you do yum install OpenSwan -y sudo cool. And then the next thing to do is to open /etc and then open up that configuration file. So let's do cd change directory to etc, and then let's nano into systemctl.com. Hey, this is future Brandon speaking. Instead of typing in those commands, I would recommend copying and pasting it just from the text note. Anyways, back to you, Brandon. And oh, I can't write onto it. I did not type on sudo. So let's do sudo nano systemctl.conf. So now I'm pretty sure we should be able to edit. Let's copy everything over here and then click on Control X, save, Y for yes. Okay, so now that I saved it, step 1 complete. Apply changes to step 1 by executing systemctl-p. Permission denied. Oops, I keep forgetting sudo. Here's a neat trick about sudo. I think if you do sudo and then 2 exclamation marks and click on enter, ta-da, it'll execute it. And okay, so far so good. The next step is to open ipsec.conf. So sudo nano ipsec. So I'm just going to copy this and paste, then save, click on Y for yes, enter. Okay, next, sudo nano aws.conf. There's nothing in here. We can copy this entire thing right over here and paste it. Oh. Okay, now here's what you want to change. Right over here where it says local and remote, it should be 10.0.0.0/16 remote, which is 192.168.0.0/16. All right, and then we can go ahead and click on Control X, save. Hey, this is future Brandon again. Just make sure that you remove the auth equals ESP and then click on save. All right, back to you, Brandon. Yes, and enter. Cool. Step 5, aws.secrets sudo nano. We're going to copy this. This is your pre-share key. This is what allows AWS and your firewall, in this case StrongSwan, to authenticate each other and establish that site-to-site VPN tunnel. Control X, Y for yes, and enter. All right, now you could do this on the second tunnel. Just do the same exact thing, rewind my video, check it out for IPsec tunnel 1. My tutorial is only going to show tunnel 1 just because it's the same concept for tunnel 2. the last thing that you need to do is type systemctl status ipsec.service. Since it is inactive as of right now. So what if I did systemctl start ipsec? And then I try that again. And now, as you can see, it is active and running. Let's go back to this EC2 instance, right? StrongSwan. One last thing to mention is over here, if you click on Action, Networking, and change source and destination check, we want to make sure that it is stop. So right here it says stop to allow your instance to send and receive traffic when the source or destination is not itself. Because essentially this is acting as a firewall, right? It's going to receive IP addresses that is not destined for this guy. So it wants to make sure that it forwards any IP address that's not destined to StrongSwan out to, for example, on-prem device. So while this is waiting to be in the upstate, over here, these are the static routes, right? On your static route, you want to make sure that your EC2 instance on the AWS side right over here has some kind of route to forward out to the site-to-site VPN and forward to the on-prem device. Hey everyone, this is Future Brandon talking. So I was recording the video and I noticed that at the very end of the video, I was unable to establish connectivity between both sides. And I realized that the issue was I actually forgot to put in that static route and I did not include that in the video. So after I made that change, I was able to ping from on-prem to AWS or vice versa. The only issue is that it wasn't recorded and I already deleted my site-to-site VPN along with all the EC2 instances with that setup. So once you go ahead and do that, you should now be able to ping from either side. And just be sure to delete everything if this is just for testing purposes, because you do get charged for having a site-to-site VPN. So keep that in mind. I know it's a super long video, but if you would like, you can always go ahead and rewind it, or if I'm talking too slow, you can always speed it up. And I hope that you know how to create a site-to-site VPN at this point. In my future videos, I'll go ahead and show you more projects on how to become a cloud support associate, so that way it's on your resume and you can use this as a way to get ahead inside your interview. So thank you so much for watching, and I'll see you later.